G'day, it's Prezzo here. I'm back in my shop today and thanks for dropping by. I'm on a bit of a mission to improve the operation of Hare and Forbes or Harbour Freight, depending on where you live, but one of these sandblasters, and this is the one that I've got, and it came with this sandblasting gun, and look, to be honest, it's not much good. I have been able to get it to work, and even though I've done some upgrades on the delivery system for this sandblaster, including making my own metering valve, I'm still finding I'm only getting about half the time, or at least half the delivery that I actually want through this gun. And I'm starting to suspect that this is the bottleneck, this is the problem. So I decided I was going to make a new sandblasting gun, and this one doesn't have its own built-in trigger. It actually has a foot pedal which delivers air, and I'm going to design this so that I can replace the internal bits. Now I'm going to reuse that cap and that ceramic nozzle on the new one. They'll fit in like that, and if you look inside this one, there's a jet just here, and this jet is a fixed size, you can't change it, and with my compressor I'm finding that it barely keeps up with the air delivery. So I'm going to try making a replaceable jet and being able to vary the position of the jet and the diameter and the taper on the end, all those sort of things. So when I designed this one, I decided I was going to make not a screw fitting, but I'm going to make just a plain bore with a couple of set screws so I can remove that whole jet assembly and play around with the geometry of that. And it's going to be just a case of trying it out to see what sort of jet sizes and positioning works best. And I'm going to use a technique where I can measure the suction. Now, in my last video I went through the process for casting this particular gun blank, and if you watched it you would have seen that I had a failure on my casting, which was really frustrating. I poured the metal knowing that it probably wasn't hot enough, and it left behind about a 2% void in the outside of that casting. So yeah, 98% of the metal went where it should, but the 2% that missed was critical. It actually made a hole right through the center. Now I have a friend who TIG welded that up for me, and Macca did a fantastic job doing that. We're here at Macca's place. He's going to bring his considerable expertise to bear on this job. Good thing is he works for beer.
Yeah, boss.
All good?
Oh, just this little bit here. There you go, boss.
Perfect. He not only repaired that missing section, but there was a little tiny void just here that he welded up, and there was a crack here that he fixed as well. And well, actually he did it for me. He sanded off all of the excess weld, and I've just done a preliminary polish on that. And I've decided that even though this was a second-rate casting, it's worth finishing it just to see whether it's going to be a success or not. Oh, and I got to tell you this. Check this out. See the number of subscribers? And that just clicked over to 3,000 this morning. So blown away was I. So thank you very much for that, for all those people who have been supporting my channel. I never expected to get to anywhere near that, so that's been a bit of a bonus for me today. Okay, so what we're going to do now is we're going to get over the lathe and we're going to try machining this. It's like an odd sort of thing to hold in the lathe, but we'll do the best we can. Okay, let's go. Right, well, that's cleaned up the bore, and I've left that about 0.1 of a millimetre undersized, so I'll run a reamer back through that later on. It'll be finished at 16 diameter. And what we need to do next is try and get this end cleaned up. And if you're wondering, I'm just taking very, very conservative cuts here. You know, with the amount of stick out that I've got and the amount of material I've got gripped in the 3 jaws of the chuck, I can't afford to be aggressive with that. Alright, it's good enough for me. Okay, well, that's prepared that end and the bore, but now I need to do this outside diameter here, and I'm a bit reluctant to do that without some sort of tailstock support. And I've got to actually machine into this shoulder here just to make it look tidy. And the chance of getting the tool digging in and tearing this thing or wrenching it sideways are pretty high. And you might be sitting there and saying, geez, Mark, you didn't think this through, did you? You should have made a little button to go in here which had a center already in it. And that way you could use your tailstock to support that part. But, well, I did think it through and I have a plan, so don't worry. So let's look at that now. Alright, one of the advantages of having more than one chuck. So I let the other part set up in its chuck, I don't disturb it. I can machine my little button here to fit the bore that I've already got, part that off, and then I can use my tailstock for support. Well, we're back with our original setup, and that little button can now go in that bore there. I just drilled right through. I knew I wouldn't be able to sort of center drill that from the opposite side after I parted off. Oh man, those parrots! We have a resident population of sulphur-crested cockatoos, and their song is anything but melodious. There they go. Okay, so now I can machine this outside surface here. It's just to make it clean and tidy, and that's all. I'm just checking here to see how much clearance I got between my tool holder and that handle, and I can make it, that's not a problem. It's got most of it. I want to leave as much wall thickness here as I can get because I want to put a couple of set screws in to hold the jet in place, so I won't go any further even though there's a bit of a defect there. I'm just assessing my chance of being able to chamfer this as well. It's going to make it, but gee, it's close. Alright, it's a bit scary. That's better. I'll blend all this later on. Okay, so it's going to give me some tailstock support, so we'll just face this off. That ceramic nozzle will fit in there tightly after I ream that hole all the way through. Well, it seems like metal shrinkage has got the better of me here. This thread I think is meant to be a 25mm diameter thread. It seems to be slightly tapered. It's really badly made. So what I think I'll do is cut a 25mm diameter thread with a 1.5mm pitch and see if the cap fits. This is already undersized. It's about 24.2. But like I said, this is a very, very badly formed thread. So if it doesn't fit, I can always go smaller. The pitch is the most important thing. The diameter is not so relevant. So I'll go ahead and do that and see what we get. Okay, we're going to try cutting this thread. I just blued that section there, and just so you know, it's not perfectly round. It's one of the issues with making castings, and you don't account for the shrinkage. I thought I'd allowed enough there, but it's obviously not. But we'll just try this, see what happens. Probably see there that it's sort of left a mark, but it's not continuous around that circumference. Alright, that'll do it. So what I can do now is ream that right through at 16mm diameter, and that'll take the ceramic nozzle at this end and the air fitting at the other end. Right, that's good. So, got to knock up an air fitting for the other end, and then we're going to work out a way of introducing the blast media up into this chamber, which is where we accelerate the blast media through this ceramic nozzle. And it's worth noting, and a lot of people have commented that said, isn't aluminium too soft to withstand the abrasion from the blast media? And the thing is that until it gets to this point, right inside the ceramic nozzle, it's traveling relatively slowly. So this is where we add energy to the flow of the abrasive media, and this is the part that takes all the wear. So yeah, look, eventually it's going to wear out, but I think it's going to outlive me. Okay, you tell me if this isn't the sketchiest setup you've ever seen in your whole life. But what I need to do is I've got to drill a 14mm hole down the center of that handle there. The drill bit has to be inclined to the axis of the top of the blast gun. There's no flat surface I can use to grip this in a vise, and I thought about how I was going to do this, and the only solution I could come up with was either to drill it freehand or to use this setup here. Now this is a brand new Milwaukee variable speed drill. I've got an older AEG drill I normally put in this fixture, but this one I can control the speed a bit better. This is my 14mm drill bit, which has got to go down at least 20mm into the handle itself, and that will later have a 16mm metric thread cut in it to take the fitting for the plastic tubing. Now I've used this drill bit to align everything. I've got the drill bit passing down the center of the already cored out hole, so I know that the angle of my compound slide is aligned with that hole. So now I've got to swap out for the other drill bit, but I can't withdraw the cross slide any further. I can't withdraw the compound any further. So what I've done is I've set my DRO to 0 on the x-axis. So what I can do is to loosen the chuck, push the drill bit in, swap out the drill bit, and come back to 0. And then very carefully drill the hole. Now at the same time I've got my spindle switched off. I've disconnected the power so that there's no chance I'm going to have anything start in an unpredictable way. And what I've got to do is get that drill bit clear. This is the other really awkward thing. And by the way, I can't turn the compound round the other way because the linear, what do you call it, the linear scale for the DRO gets in the way. So I'm stuck with this. So, let's see. That's it. So now I'm going back to 0 on my DRO, which should be there. Okay, I'm going to lock my carriage at that point. Alright, this should be fun. That was successful. So what I can do now is tap that at M16. So this is my 16mm tap. I've just released the gear mechanism on the drill, so that's spinning freely. I just want to get this started to make sure it's aligned. And these keyless chucks aren't good for this, they'll start to loosen off. Yep. So that's about as far as I can go. Okay, now don't judge me here, I just want to get this started. Alright, just made it. Okay, so I can go ahead and tap that in the traditional way now, and then we can make up a fitting for the clear plastic tubing to deliver the media to the gun. Just probe that to find center on Y, so now I can drill 2 tapping size holes for grub screws so they can hold that temporary jet in place. Okay, well that's taken care of the body of the gun, so now we can fit the jet temporarily, do a few tests and see if we're on the money. Okay, well that's my very basic test jet, and it's got a 2mm diameter hole in this end, 6-degree taper on this section, 16mm diameter, and the back end is bored out all the way down to about within 20 to 30mm of the end of that jet. So as I test this, I can progressively drill this out bigger and bigger, and I can move this in and out inside the gun body itself. Here are all of the disassembled parts for this DIY sandblasting gun, and I put it all together and I have tested it, and I can reveal at this stage I'm getting a 35% increase in suction compared to the original gun that came with this sandblasting cabinet. So that much I'm very happy about. Now that's just testing suction only, so I'm not really testing delivery of the blast media at this point, but I will do that. So the way this works is that we can fit the jet into the back of the gun, and that can be moved up and down. We can test the position of that to give us the best delivery. So if you look down through the center of the gun, you can see the jet there, and that's pretty much the same system that is used on the old gun. Alright, the next thing is we can reuse the ceramic nozzles, and we can hold those in place for the cap, so it's possible to swap out those nozzles very quickly. Now the jet size itself is also able to be fine-tuned by drilling it out. Now I've started with a 2mm diameter, and I'll gradually increase that by 0.25mm at a time. This is the fitting that takes the plastic tubing that delivers the blast media, and that just simply screws into the base of the handle. And we can fit either a Nitto style quick release coupling to a 1/4" BSP thread in the back of the jet, or we can fit a barb that will take the same diameter tubing as the pneumatic tubing that we would normally use for this fitting. So depending on how you want to use this, you can swap out either one. So at this point I'm very happy with the way this has gone. I was glad that I was able to get that defect welded up in the casting, but I am going to do this casting again. I've sort of learned a lot from working with this one, and this was sort of turned out to be a prototype anyway. So the new one will have an improved design of the passage inside where the blast media and the air mix. It'll have a tapered section toward the front and the rear. I'm going to make the body of this slightly bigger. I think I'm going to do away with this part altogether. It's really not necessary. I initially thought I could use this to hang it up inside the cabinet, but it's probably pointless. So, and this jet, I'll probably make that from something other than aluminium, maybe steel or brass. And a lot of people have commented that, you know, this is too soft. You know, I don't believe that's the case. This one here, that jet is made of brass. It seems to have survived okay in that gun. So join me on the next video. It should be out in about 2 or 3 days, and I'll show all of this testing process that I've used, and then we'll actually put it in the blast cabinet and see if we're getting improved delivery through the nozzle here. So yeah, it's come on better than I thought, and the new one, I'll reveal this at this stage, will have lightning bolts on the side of it, which is apparently a very popular request. So I've taken that on board, and we are going to do that. So tune in to see how that goes later on. I've also come up with a new method for making core boxes. Now this is for an unrelated project. I'm making a bandsaw guide for an old cheapo bandsaw that I was given. I want to convert it to a metal cutting bandsaw. But you would have seen the struggle I had if you watched one of the previous videos trying to remove the cores from the core boxes. So these ones are actually flexible, so you can stretch them apart to remove the core from the 3D printed core box. So that's an exciting development that we're going to look at in a future video as well. So check that out when it comes out. And I think initially I said that I was up to just over 3,000 subscribers. Well, that's now about 3,250. So I don't know what's going on. It's a bit strange. But yeah, suddenly I'm attracting all these new subscribers, which is great. That's fantastic. So keep that up. Okay, that's all for now. Check me out in the next one. See you later.